All right, welcome back, and now we're going to do an example here. So this is another product of two functions. So let's look at this function. So we have f of x is equal to x squared times sine of 3x. So the first thing we need to do is understand the behavior of each of these functions separately, okay? So one thing is let's look at x squared, right? So x squared, we know x squared is always going to be what? Oops. Greater than or equal to 0. Right? And what do we know about sine of 3x? Well, sine of 3x we know is going to bounce between 1 and -1. So we know that the absolute value of sine x, or sine 3x, is what? It's going to be less than or equal to 1. And greater than or equal to 0. Okay? So if we put both of these together, then we know that x squared times sine 3x, the absolute value of 3x, is going to be what? Less than or equal to x squared and greater than or equal to 0. Okay? Now, if we drop the absolute value, this all then, which gives us what? It means that x squared sine 3x is going to be between what? X squared and negative x squared. Now, what else can we say? Okay, well, we know it's going to bounce between these two, right? Well, we know what kind of graph x squared is, right? It's a parabola. So this is an upwards parabola. This is a downward parabola. So this parabola opens upward. This one opens downward, okay? So right away, what do we have? We have something that looks like this, right? So we've got two parabola. Right? So it looks like that, right? And the sine function is going to bounce in between those. Now it's got a factor here of 3, but that still means it's going to be a horizontal stretch or compression, right? So in this case, it's going to be squeezed, but it's still going to bounce between these two parabola. So now, what else do we know? Well, we know it's going to bounce, but when is it going to touch this, either this or this one, right? So again, when does it cross the x-axis, and when does it touch either parabola? Okay, well, let's go back to this, right? So we know sine 3x. When is sine 3x going? Okay, so we know, let's start with this. We know sine x is going to cross the x-axis. There's going to be a y-intercept when what? Okay, when what? When x is equal to n times pi. Okay, well, when is 3x equal to a multiple of pi? When x is a multiple of 1/3. Right? Think about that. So sine of 3x is going to equal to pi when it's 3 times what? Pi over 3. Okay? Or when it's 2 pi over 3, or 3 pi over 3, or 4 pi over 3. So some multiple of pi over 3. So guess what? Sine of 3x will equal 0 when what? When x equals some multiple of pi over 3. Okay? Now when is it going to equal either negative x squared or positive x squared? Well, when sine of 3x is equal to 1 or negative 1. Okay, when does that happen? Well, we know that sine x equals plus or minus 1 when x equals pi over 2 plus plus n pi. Now, so how is this going to work? When do we get pi over 2? Well, when is sine x equal to pi, oops, hold on. Well, so yeah, when is, hold on, plus or minus 1. So when is sine x equal to plus or minus 1? Well, we know that here. So when is sine 3x equal to plus or minus 1? Well, again, we need to get pi over 2. So when do we get pi over 2 in this as an argument inside here? When x is pi over 6. So that means that sine of 3x is equal to plus or minus 1 when x is equal to pi over 6 or plus n pi over 3. And then when we put it all together, we can sketch the graph. Because all we have to do is mark out where all the x-intercepts are, right? When do those occur? And when do the points touch along either one of these, right? And then all we have to do is sketch the graph. Okay, that's it. And of course you're going to get something that maybe looks like this. I'm just drawing the graph, so this is just, so it's going to look something like this. You know, something like that. All right, that's it.